going to move on now to our tech corner. Dirk's going to jump over there in a minute, and this one is with Dirk and Rob Bellinger. Rob, again, is our expert who joins us from Olympus. This one is the Olympus CIX90 Technical Cleanliness Inspection System, and again, it's presented by Rob Bellinger, Product Application Manager for Olympus Industrial Microscope Division. So Dirk and Rob, take it away.
All right, thanks, Mike. Well, Rob, welcome,
nice
welcome
to
back
see you
once again.
Yeah.
So this is a particle inspection, cleanliness inspection, looking for particles on what type of things?
Filter media for this
okay.
system. So this is our cleanliness inspector, model CIX90. It's a new platform, new hardware platform compared to our old system. It's a fully hands-free system. There's no sliders or mechanisms that the user's going to have to interact with on the microscope hardware itself. So that automates the process even further. Another feature is a new illumination method. This allows the scan to capture 4 types of particles all in one scan, which is twice as fast as it used to be.
And just to be clear,
So,
these filters would come out like machining centers, that sort of thing, looking for debris and lubricants and oils and.
Typically, manufacturers are looking for quality assurance that the parts are clean after they've manufactured them. So metals or fibers or large particles don't clog like injector assemblies or hydraulic assemblies. So you're going to see a lot of automotive manufacturing, a lot of industrial manufacturing, but it could be even medical device parts, things that are going to be going into satellites as well. So a lot of space research and cleanliness is a very important factor for those, of course.
Sure.
So they're going to rinse fluid over the material they're manufacturing, capture it onto a filter media, and they want to quantify all of that data. They want to count the total particles, they want to size them, they want to know if they're metal, they want to know if they're reflecting fibers or just standard particles. So with the new illumination method, it's scanning. In one scan, it captures all that information, regular particles, fibers, reflecting particles, and reflecting fibers. So along with the new system is a whole new user interface as well. We have new software that they've streamlined and made very user-friendly, meant for any operator to walk up, pop on their filter assembly here on the stage, a new filter cap that locks down the filter, flattens it out for easy scanning capabilities. Then the operator is going to come right to the screen, and it's a nice touchscreen system now, so it makes it easy interface. They're going to hit run inspection, and this uses a very low mag lens to do a quick overview scan. So it says down here in the bottom right of our software screen, acquire overview image. So if they hit that, it's going to start doing an autofocus. So the Z is also automated on this, or the user doesn't have to go and try to focus on anything. After it does the autofocus, it acquires an overview scan. So this overview scan is used for a couple things, for them to make sure everything looks good as far as the sample surface of the filter, and to also take a look at where their flow-through areas, where the water actually went through or something on the filter paper. So that takes just a few seconds. The next step in the process is going to ask them for an inspection configuration. So this configuration is going to set the microscope up. It's going to set up the standard that they want to use. And if you look on the right here, it describes everything on the screen of what it's going to scan with magnification-wise, the standard they want to use. Even has a great area for them to type in a lot of descriptions. They might use different inspection methods, configurations for different parts. Different types of materials might have different requirements. So once they select what they have here, they simply hit next. It's going to select the right mag. As it's doing an autofocus here, it's refocusing the system. You can see on the right-hand side of our screen, it brings up a bunch of different sample ID fields. This is customizable by the user. Different fields, they might have serial numbers they want to track, part numbers, lot numbers. They're going to enter that information into these fields here. So one of the fields that's highlighted down here is a required field. This standard that we use requires the number of parts that we've washed the rinse fluid over.
And it's all configurable, I'm assuming.
These are configurable in the system configuration files, yeah. So by selecting that, the fields might change for what they want to use for that part. And then once they have the fields filled in with what they want, they can even type in comments. They're going to come down here to inspection settings. So these settings can be sort of automated if you're running a same sample and it's always repeatable. These can just use auto functions, so they may or may not interface with these, but for the demo purpose, I want to show, the adjustment of thresholding. As I adjust this, I want to make sure it's marking the particles that we want to detect. And this is a live image, so if I move around, you can see that the particles stay highlighted everywhere we go, so you can verify you're detecting properly. Again, that can be saved, and the configuration file is an auto function as well. The other couple steps are to set the scan paths. If they need to adjust the scan path, that's what this overview image was for here in the middle. So if they need to shift their scan path because their flow-through area shifted a little bit, they can adjust that down here. Once they make all these adjustments, they're just going to hit Run Inspection. So now what it's going to do is go through and capture a few points of focus on the surface of the filter. This is to correct for not only tilt, but it can be set up to correct for waviness of the filter paper. Because sometimes they get dried and they kind of potato chip. So the system does this fully automated, goes through and autofocuses at multiple points, and it's going to create a topographical map as it does the scan. So this takes a few seconds for it to capture those focus points. Once it's done, it'll start doing the automated scan. So that's what we're seeing here. In the sample overview image, this shows you the process of the scan as you're going through. You can even see if we have a view of the live stage scanning on the system as well.
Oh yeah, if we switch to the switch to the software shot. Okay.
So in here, you're going to see the live images flashing by just to show that it's detecting particles. If something was wrong, you'd see it right away. On the right-hand side, you're seeing your approvals. So in our standard, we said particles need to be separated into bins, 5 to 15 microns, 15 to 25 microns.
So it's counting them as it goes along.
That's those bins that you see here. Now, one of these bins is, now 2 have turned yellow. That's went over our maximum allowable amount of particles. So right away, the software is telling us in a live scan, this was not a good scan, which failed a couple of the bins. Once it's completed with the scan, you see it moved really quick. Again, that scan captured particles, reflecting particles, fibers, and reflecting fibers all in one scan. We can see our bins, our total counts here. This allows us to move around real quickly just to kind of get a view. If something didn't look right, we could just jump back to do a rescan. But if we're confident in our values here, we can move on to review the results. So under this selection,
oh, that's interesting.
yeah, another neat thing about the software, and for traceability, going back and looking at stuff later on, every single picture of every single particle is captured here as it did the entire scan over the filter paper.
And you could filter these by
right now
particle size, right?
Right now it's filtered by size. So if you select this one in the top, not only does it select which bin that it fell into down here, as far as its sizing, but it's going to move the stage. I don't know if we saw that quickly, but every one you click on, the stage will actually drive to those points.
Oh, so you could actually go and actually examine that particle.
You can, you can switch right here to live observation. So you can see that particle in live observation. So if I move the joystick around, you'll see the particle move on the image screen. Going back to our particle list, the only other thing that might be of use is if you wanted to see just those reflecting particles. Some customers are very concerned with their metal type particles. If they have any, it's a failure. Or they want to make sure that they're not a certain type. So you can actually drive to these particles as well. See them in the live observation. They're kind of a reflecting metal particle.
Shiny,
Yeah, so we call those reflecting particles. You can sort those as well. Once they review all of their results, they will want to take the next step and create a nice report. So at the end of the process up here, we create report. We can select from multiple different templates. You can have custom templates for different parts and have different requirements in the templates. These are just Word document templates. We can create either a Word document or a PDF document down here in the selections for output. Once we do that, we just hit Create Report. We assign a name to that report, and it's going to take all of that data, compile it into the document for us.
And that document can be a template that you create to select what kind of information you want in there?
That's correct. The template's going to, here we'll see in a second, it'll have your logo in the top, so you can adjust that. You can say all those fields that we entered at the beginning, those insert automatically if you want to show them in the report. So if you need to have your customer name or your part number showing right at the top, you can adjust this template to have it wherever you want. As you scroll down, page 2, we have it set up to show our bin classes again, all the different sizing of particles and their total counts. And again, it shows you in here if it passed or failed which bin. And then we show the top 10 largest particles and all of their measurement results for each particle. And down a little further, we have the top 10 largest particles in picture format. Again, this is a Word document, so you could save this out if you needed to email it off, or automatically it's saved into the data pool of the software. So if we go back and look at the software, we're done with our reports, we'll go home. You can see that later on, the important thing is qualifying all this data. And later on, if it failed in the field or something, a part that you manufactured, you could go back and look up that serial number and pull up all the results again. So we could show our results, go in here and select them one more time, and it brings up all those pictures again. You can also open the report. Everything is automatically saved and archived in the software, so that there's no user has to remember to save it. They forgot to save it. The data is just always there as soon as the scan completes.
Okay.
That's great for traceability for the customers. But that's the workflow. It's pretty simplified.
This is the CIX90, and I believe you said this is faster, quite a bit faster than previous versions, because you do everything in one pass, right?
That's correct. Our old system was, our filter inspector system required 2 sample scans. One scanned particles, and then another whole scan to do just the reflecting stuff. And the user had to interface with the hardware. They used to have to slide in like a polarizer system and adjust to counteract reflecting particles, and then pull that out at the second scan. So this fully automates that, takes the human element out of having to slide sliders in, and it does it all in one scan, so it's really twice as fast.
All right, so the CIX90 Cleanliness Inspection System.
That's
right?
correct.
From Olympus. Rob, thanks.
Yeah,
Thanks again for joining us.
Yeah,
Okay,
no
Mike,
problem.
back to you.
Well, there you have it. Yes, Rob Bellinger, Dirk Ducharme with Olympus' CIX90.